Alright, this video we gotta talk about pH and pOH and all the concentrations in between. So your goal after this video is to understand what it means if you have a high pH or a low pH, and you should be able to calculate the pH, the pOH, the concentration of the H, and the concentration of your hydroxides. So what is pH? pH is a measure of your hydrogen ion concentration. It's from the German word potens hydrogen, or the power of hydrogen. And you'll see why in a little bit when we get to the formulas. Acidic compounds, or solutions that are acidic, have a low pH. A lot of people think that if it's acidic, it has a high pH, and that's not true. Basic compounds have a high pH. And if we see the solution of water, we see that we have a dissociation of hydrogen ions and hydroxide ions. Let's take a minute. What is pH? Pause the video, go back if you need to. So when we talk about pH, we usually use a scale from 0 to 14. And if you are on, go back. This side of the spectrum, so less than 7, you're considered an acid. And so that's like your lemon juice, tomato juice, all the stuff in your stomach are all acidic. And what that means is that they have a high concentration of hydrogens. And you miss, how can it have a high concentration and have a low pH? Again, we'll get there when we get to the math. Just be patient. On the other side of the scale, if you're greater than 7, from 8 to 14, you're considered a base. And so that's stuff like bleach, ammonia, that's that yellow smelly stuff that people use to clean, hand soap, baking soda, all of that stuff is super basic. It doesn't have a lot of hydrogens, but it has a lot of hydroxides. And in the middle, we use as a base, as a standard, I guess would be a better word. We have water. Water's we consider neutral. I mean, we have different versions of water now. You can buy alkaline water, you can buy slightly acidic water, but in general, water is about 7 in its pH. So that means that it has an equal amount of hydrogens and hydroxides. So take a minute. If a substance has a pH of 4.3, is it an acid or is it a base? Go back in if you need to check yourself. Oh, you're a 10 on the pH scale because you basic. Oh. Alright, so back to this idea of high and low hydrogen hydroxide concentrations. As we said, the acids have more hydrogen ions while the bases have more OH ions. And if we look, it's a balance. If you have an acid, you have high OH, low OH. With the bases, it's the opposite. With your base solution, so if I add bleach to water, my OH concentration is going to go up and my H concentration is going to go down because those bases are going to be accepting the hydrogens, as we talked about a couple days ago. If your solution is neutral, they're generally equal. I mean, sometimes it fluctuates a little bit, but overall it's equal. So take a minute. If my hydrogen concentration is low, the hydroxide concentration, is it going to be high or low? Go back if you need to check. Alright, let's take a minute to think about this kind of problem. Sometimes I like to add lemon juice to my water, but now we gotta think about, well, how does that change my pH? And what happens to those concentrations of the hydroxide and the hydrogen ions? So let's see, here's my glass of water. Here's my lemon. And there's the lemon juice all distributing throughout the water. Well, lemon juice is acidic. So that means that my lemon has a hydrogen. I mean, I'm not going to give you the actual chemical formula of the citric acid. We'll just say it has a hydrogen on it for simplicity. And we mixed it with some water. Well, acids want to donate their hydrogen, so this hydrogen is going to want to hang out with the water. So then I have my lemon juice. That's now negative because it lost a hydrogen. And my H3O concentration went up. And as we talked about a couple days ago, your hydrogen concentration is pretty similar. I mean, most people interchange them with your hydroxide concentration. And so what we see is that our concentration of hydrogens is going to go up because all of these hydrogens are now released from the acid. But our pH, because lemon juice is so acidic, pH is going to go down for the water. Our pH of the water was 7, assuming it was pure water. But when I add lots of hydrogens, my pH goes down. So our hydrogen concentration and our pH have an inverse relationship. And again, if our hydrogen concentration goes up, our OH concentration goes down because all those OHs are binding with the hydrogen. All right, on the flip side, let's say I added a base. Let's say I have to clean my bathroom, I have a bucket of water, I add some bleach so that it can disinfect everything. So here's my bucket of water. And here's my bucket of bleach. And there's all my bleach going in the water and distributing. So my water and my bleach are going to be mixing together. Well, bleach is a base, so it's going to accept hydrogen. So water is going to be giving up its hydrogen. So then we'll have OH minus, and bleach will be a little bit more positive with that extra H. So what we're going to see is that the OH concentration is going to go up and my hydrogen concentration is going to go down because all my hydrogens are going to be bonded up with the bleach. The pH, because bleach is so basic, our pH is going to go up because water's at 7, assuming it's pure. And if I add up something that has a pH of 12, it's going to push my pH higher up. 7's over here. It's going to be pushed up closer to 12.